Can you see the screen?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Have you seen the backgrounds?
Yes, ma'am.
What is it?
It is a kind of waterfall and a hill station.
Waterfall. Yes. Do you know where it is in Karnataka? It is in Chikmagalur. Okay. Chikmagalur is the Switzerland of India. All right. Whenever you get a chance, come to Chikmagalur. All right. Okay.
ma'am.
So now we will go to the classes. Anyway, you can see my screen, no?
Yes.
Yes, ma'am.
We are studying about acids, bases, and salts. Can you say what is an acid? How do you know that a substance is an acid?
Having a pH.
No. pH? Yes, come on.
pH level below 7.
Sour in taste.
Yes, very good, very good. pH level below 7. For an ordinary person, how they can find out a substance is an acid? We cannot
Sour
see
in taste.
right? Can you give an example for a substance which is acidic in which we see in our day-to-day life?
Vinegar.
Yes.
Vinegar is acid.
Lemon.
Lemon. Yes.
Baking soda.
Citrus.
Citrus fruits, tamarind, all these are acidic, which are having sour taste, isn't it? And what are the bases?
Soap.
Soap, which are slippery. Most of the bases are slippery and they have bitter taste. One more thing, we cannot test a substance by tasting. Never do that because it may be edible or not edible. So never test an acid or base by tasting. Always we must in a laboratory, okay, we know it's lemon, we know lemon is acidic. It's all common thing what we see almost in our day-to-day life. But an unknown thing, don't check by tasting. Okay. In a laboratory, how to test whether a substance is acid or base? You see, some are acidic substances you can see in your screen. You can see now.
Ma'am, it's stuck in
No,
the
ma'am.
first slide.
Screen sharing is stuck.
Huh?
It is
Your
stuck in
slide
the
is
first
stuck in the
page.
first slide.
Is it? It is still in the first slide, it seems. Maybe net problem, children. I will stop sharing. Please wait. Now can you see? No.
Share it. Share. Window. Share.
First slide. Is there on first slide? Not issue. Another slide. Children,
Yes, ma'am.
can you see?
Yes, ma'am.
Now the heading is, the content is acids are substances with sour taste, whereas bases are substances with a bitter taste. Is it okay? Can you see?
Yes,
Yes,
ma'am.
ma'am.
Okay. I am going to change
ma'am.
the next slide. You please see whether it is visible. Children, is it visible?
No, ma'am.
No, ma'am.
Okay, I will once again open. Slideshow and slideshow. Stop here. Net speed okay. Then ഇത് ഓപ്പൺ ചെയ്യാം. Children, I'm going to close this PowerPoint.
നമ്മൾ ചെയ്തിട്ടുണ്ട്
Close it. Notice your
സ്പീഡാണ്
speed. Slideshow
ഷെയർ ചെയ്തിട്ടുണ്ട്
Children,
Yes, ma'am.
is it visible?
Acid bases and salts that.
Okay, next one. I'm going to change to the next one. Is it visible?
No, ma'am.
No, ma'am.
What is
Yes, sir.
visible or not?
No, ma'am.
No.
Ma'am, now
Yes, ma'am. Now visible.
Now visible. Okay. Okay, then whenever I have to write something, then only I will go to slideshow. Okay. I don't know whether it will be visible or not. Maybe net problem. It's a hilly area. Children, it's a hilly area. Maybe because of. Now you see, carbonic acid. You see, this soft drinks. Soft drinks are all one or another way. In that main component is carbonic acid. You know, carbonic acid is H2CO3. Okay, sulfuric acid used in car batteries and paints. Tartaric acid, that is part of. In which substance tartaric acid is present?
Wine.
Wine, tamarind, isn't it? Nitric acid is used in fertilizers. The acid present in our stomach,
Hydrochloric acid.
hydrochloric acid. And medicine called aspirin, you know what is it used for?
No.
or painkillers.
Heart attack patients, those who are having heart problems, one tablet they keep in under the tongue, you know, that main content is salicylic acid, and vinegar contains
Acetic acid.
no. Yes, the dilute solution of acetic acid is vinegar. Citrus fruits contain citric acid. So many substances are daily used in our day-to-day life as, and they are acids. So acids have a lot of applications. That's all. Next, bases. Can you see the slide?
Yes, ma'am.
Okay. Bases, you know, in washing soaps, antacids. Antacid. What is antacid? What is antacid? Medicine used to decrease the acidity of stomach. Okay. Medicine used to decrease. Are you having notebooks with you?
Yes, ma'am.
All of you keep notebook with you, write what you are listening, at least the point. Okay, when you go back, when you evening time and all, you can go through this. So as the medicine used to decrease the acidity of stomach is antacid. Okay, we'll go to next step. See, how we indicate or how we find out that a substance is acidic or basic in the laboratory. You know, you have studied in lower classes. What are
Litmus paper.
Indicators.
indicators and examples?
Litmus,
Litmus paper.
Yes,
turmeric also.
yes, litmus, phenolphthalein, methyl orange,
Then
turmeric. What else? Anything else you know?
Purple cabbages.
Cabbages, red cabbages. Then hibiscus flower, its extract. These are all natural indicators. In the laboratory, we use chemicals as indicators. Even extract of a plant called lichen, that is litmus. Okay, there's litmus are of two types, you know, blue litmus and
Red litmus.
red litmus.
red.
Once again, I am trying to make it slideshow. You must tell me whether it is visible or not. If it cannot be made like that, I cannot write anything. That is a problem. Okay, I will try. You please cooperate with me. Okay, children, can you see?
No, ma'am.
Okay.
Madam, once you write it and then you go out of slideshow, maybe then we can see what you have written.
Actually, there are pen tab which I used for writing. So if we make it slideshow, then only that pen tab works. That is a problem. Okay. So litmus solution is prepared from, remember children, it is prepared from a plant called lichen. Okay. And we know what is this is lichen, the plant lichen. Can you see now?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, I'm going to the next. I don't know if I cannot write, it will be very difficult. Okay, we'll see next. Color changes with the litmus. We will see an activity. Can you see the slide?
Yes, ma'am.
See, in the laboratory, I have done it and I have recorded. You tell me whether you will be able to see it or not. Can you see the activity?
Ma'am. Yes, ma'am.
Okay, you have used in lower classes this litmus. This is blue litmus. It is dipped in sodium hydroxide. So you can see now
Yes, ma'am.
what happens. Nothing happened, no? Now it is dipped in acid. Dilute HCl. What happened?
Color change to red.
Yes.
Change
Blue
into
litmus
red.
changed it to red. Okay. And now we see blue changed it to red. Now red is dipped in acid. Red litmus dipped in acid. What happened?
Nothing happened.
Nothing happened. No change. But when it is dipped in base, you see what is happening. What happened?
Color changed to blue.
Red changed to blue. Okay. So what we can confirm from this? You tell what we can confirm.
If we
Acid
use
changes. Acid changes
blue into red.
blue into red, and base does not have
Any color change for blue.
any color change with the blue litmus. Are you writing?
Yes, ma'am.
Similarly, base, what is the reaction of base? Base changes
Red into blue.
red into blue and base changes red into blue, but the base does not make any acid does not make any change with the
Red litmus.
red litmus. Okay. All right. See? So acid changes, blue into red, and the base changes
Red to blue.
blue. Okay. Next. Another activity that is with the litmus solution. We'll see. See? First one is, you can see this video? Can you
Yes,
see
ma'am.
this video?
Yes, ma'am.
Yes. First one is litmus red. See, this is litmus red. Okay? I'm pouring it to sodium hydroxide. What happened? Red changed to blue. Same red is poured in acid. Same red is poured in acid. What happened? Children, are you observing?
No changes.
Yes, ma'am.
Red is remaining as red
Red
itself.
itself.
Now blue
Red.
litmus, I am pouring to NaOH. Blue litmus is poured into NaOH. Any change?
No.
It is blue. Okay. Then blue litmus is poured into HCl. It is changed to
Red.
red. Okay, children. So not only litmus paper, with the litmus solution also we can do this experiment. All right. In both the litmus paper and litmus solution, same changes are there. Okay.
Yes, ma'am.
Okay, next one. See, this is another indicator, phenolphthalein. Phenolphthalein and methyl orange. Both are indicators used in the laboratory. Okay. Have you seen it in the lab? Hello.
Yes, ma'am.
Have you seen these indicators in the laboratory?
Yes, ma'am.
Yes, ma'am.
Phenolphthalein, children, phenolphthalein is colorless. No color for phenolphthalein. Okay? And methyl orange, we will see what its color. We will see the activity. What is the color change with the phenolphthalein and methyl orange? See, phenolphthalein in dilute HCl, methyl orange is added. You see, what is the color?
Orange.
Orange. What is the color with base?
Yellow.
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 You must write. Afterwards, we will see that actually I wanted to make you write. I wanted to write, but see, now you understood now color change with methyl orange?
Yes,
1
ma'am.
minute, we will go back. I don't know how many of you observed. See, I'm taking methyl orange and adding to dilute HCl. Okay, what is the color change? It became orange. And with the base,
Yellow.
yellow. Okay, you noted it?
Yes, ma'am.
Okay, with the base, methyl orange gives, with the base, methyl orange gives,
Orange color.
no,
Yellow.
no,
Yellow.
base is NaOH. That NaOH, with NaOH we have seen yellow color, no. So with the base, NaOH, orange, this methyl orange gives yellow color.
Yellow
And
color.
acid, methyl orange
Orange.
gives orange
Orange.
color. See it once again. Methyl orange with acid, orange color, with the base, yellow color. Okay. Next, with the phenolphthalein, we will see with the phenolphthalein what is the color change. With the phenolphthalein, what is the color change? So I'm going to, it is added in NaOH. What is the color?
Pink.
Pink. Pink. So with the base, pink color, and with acid,
No color change.
are you sleeping, children?
No color change.
You have seen it? That is the methyl orange. Okay, next. Phenolphthalein to NaOH. See, pink color and with acid, colorless, no color.
Colorless.
No color. You have noted down?
Yes, ma'am.
Phenolphthalein with the phenolphthalein, base gives, with the
Pink
phenolphthalein, base gives pink color.
Pink
And
color.
acid,
No color.
no color. Colorless. So what we studied, these indicators with the litmus, acid changes,
Blue into red.
red, base changes.
Red to blue.
Red to blue.
The same is with the litmus solution also. Then with the methyl orange, acid changes.
Acid changes to yellow.
Orange. Acid changes to orange. And the base,
Yellow.
okay. Phenolphthalein, acid,
Colorless.
yes. Base,
Pink color. Pink.
okay. Now once again I will try whether I am able to write or not, okay? I'm worried really. Okay, some more experiments we'll see. Then we will. Can you see this screen?
Yes, ma'am.
Universal indicator. Another indicator is called a universal indicator. Okay, it is a green colored solution. And what happens with acid and base? We'll see. Are you interested in activities?
Yes, ma'am.
Okay. Okay. What is it? Universal indicator. Okay. This is a base that I have not noted. What happened with the solution? What happened?
Turns purple.
Yes.
Your video is
Universal indicator is green colored. Okay, it changed it to blue. You note it down in the book. Universal
Ma'am, your
indicator.
video is stuck.
Video stuck.
No, ma'am.
No, ma'am.
Is it visible?
Yes, ma'am.
Yes, ma'am.
Yo, I don't know. I wanted to show you all this. Now see, it is a base. All right. It's a base, and I am having universal indicator in my hand. It's added now. Is it visible now?
Yes, ma'am.
Okay. Okay, that is green colored. It changed it to blue. Okay. After I will ask you all this together. You must tell me. All right. പിന്നെന്താ അല്ലല്ലോ എന്തോ ഒരു വിഷയമുണ്ട്. Now next is acid. Okay, that universal indicator is added to that. You see what is the color change? Can you see?
Yes, ma'am.
Yes. See what happened. It changed it to
Orange.
red, almost red only. You see, it's red. Okay. So in all these cases, we can see that color change of litmus, universal indicator. These are all acid is changing to red, isn't it?
Yes,
And
ma'am.
as it is, color is changing to red. Then base, the color change is to
Blue.
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 Bluish
So in
white.
that way you can remember it. All right. So what is the color change when with the universal indicator?
Acid into red
Acid
and
As
base into blue.
universal
Acid
indicator
into
is
red
green
and
color.
base into blue.
Yes, yes. Okay. Next, you see here a picture. You can see that color chart, universal indicator color chart. For neutral solution, it is green. Okay, and for base, it is changing to light green, then blue and dark blue. Can you see?
Yes, ma'am.
Okay, towards left you see is slightly acidic means yellow, then to slight orange, then to red. All right. So that is that color pattern of a universal indicator. Here all I wanted to write. Okay. Anyway, we will manage. Now you
Madam,
see. Children, tell me.
why don't you try that draw tab in the ribbon? Maybe it will work.
Which one? I could not understand. You tell me.
Madam, that draw tab in the ribbon.
Draw.
Yes, ma'am.
Nice. In the slide itself, I can write, no?
Yes, ma'am.
Yeah. In the penta, with the penta, I think you can write. Draw. Actually, with the penta, I was trying my children what to do. Children, they know all these techniques more than us. I have taken, but not writing. With the pen only I can write it. Show on space. Once again, a slideshow. Can you see this?
Yes.
Can you see the screen?
Yes, ma'am.
Oh, okay.
Yes, ma'am.
Then it will be successful. Now we will see the natural indicators. Okay? Can you see this?
We can see the table.
Oh, table. Now I changed it to next. Table you can see now?
Yes, ma'am.
Table we can see, ma'am.
Okay,
Ma'am,
okay.
it's not in slideshow format.
Huh?
Ma'am, it's not in the slideshow format. It's in the preview.
It is in the slideshow actually. I have given in slideshow only. Now it is not in the slideshow, but I made it slideshow. In slideshow only we can use the pen tab. Pen tab. Now can you see the screen? Blank screen?
No, yes,
Yes,
ma'am.
ma'am.
Ma'am, we can see it, but it's not in the slideshow.
Okay, you can see now.
Yes.
Can you see what I am writing?
No, ma'am.
No, ma'am.
So now next is severe problem is there, children. This way. Can you see what I am writing?
No, ma'am.
So better not to waste the time. We'll go to next. Can you see now?
Yes, ma'am.
Yes, ma'am.
Okay. So we'll go to next activity. All right. Then we will write. This slide, can you see?
Yes, ma'am.
Yes, ma'am.
Okay. Now we see many natural indicators are also there in addition to our phenolphthalein, methyl orange, litmus, even this red cabbage. Red cabbage figure, can you see?
Yes, ma'am.
Yes,
Red
ma'am.
cabbage. One thing, you don't try this acids and all at your home. But acidic substances are there, isn't it? Lemon juice. We can make an extract of this red cabbage or a turmeric solution and try with the soap solution, then with the lemon juice, and you record your activities, what color change you are seeing. Okay? So I will show that one activity. What I did not get red cabbage, but I got hibiscus flower and turmeric. Its extract is made. Can you see this?
Yes, ma'am.
See, children. The one is hibiscus extract, another one is turmeric solution. This NaOH is added to, NaOH is taken in a test tube, and you see, it is hibiscus extract. You see the color change. Can you see?
Yes,
Because of
ma'am.
my saree color, it is now you see green color. It is green color. Okay. So you also can try at your home. Make a hibiscus extract and then add this lemon juice or a washing soda. Now we see dilute HCl is taken and this hibiscus extract is added to that. Hibiscus flower. All right. See the color change. What happened? It became
Red.
red. It became red. See here also acid is changing to
Red.
red. We cannot generalize it. Now we see next sodium hydroxide is taken. To that turmeric solution. Turmeric solution is added. Turmeric dissolved in water only. It is added. You see? It is becoming light red, orange. Isn't it?
Yes, ma'am.
Okay. And then with the base, what happens with the turmeric? We'll see. Base is taken. Now acid already it was taken, no? Acid, it was acid. Earlier it was base, no?
Yes, ma'am. Earlier it was base.
Yes, sodium hydroxide was taken and turmeric was added. You know, to make this kumkum, what technique is used from turmeric? Turmeric solution is mixed with the washing soda or soap. Okay, you can try at home. No, it is acid only. This one is acid. What you are seeing is now action of acid with the turmeric. No change at all. It is remaining yellow itself. Previous one I will show once again. Hibiscus we have seen, isn't it? Hibiscus extract is added to. Base is taken, hibiscus extract is added to that. Okay. Now it is a light green color, light green. Okay, now that board you can see. In front of the board you can see that light green color. All right?
Yes.
Hibiscus with the acid we will see. That is dilute HCl. And the hibiscus extract is added to that. See? It is becoming red. What is taken first?
Base.
Now, base with the hibiscus, green color. Acid with the hibiscus.
Red color.
Gives red.
Now NaOH is taken, turmeric is added. Here we cannot see that phenomenon. Here it becomes red. You see? Here it becomes red. This turmeric becomes red with the base. Always remember, here it is different, not in the case of other cases. Almost in all the cases we have seen this acid changes indicated to red, but here base changes the indicator to red. Have you noticed?
Yes, ma'am.
Remember, for making in large scale kumkum, sindura, that is made using turmeric. Turmeric is mixed with soap. You must try at home today itself. Turmeric, mother will scold you. Hey, whatever turmeric used for cooking, you are using for all these things. Huh? Anyway, you convince your mother and use it. Do it. Okay? Little turmeric you take, mix with water and add soap. It becomes red. Acid. Okay. Okay. So, acid changes. With the turmeric, what happens?
No change.
No change. With the
Acid.
acid. And turmeric changes to
Orange, red.
orange or red. Actually, if it is concentrated, it becomes red. Orange or red with the
base.
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 Sorry,
Okay.
base.
Soap is basic now. Soap is basic. All right. So you can try it, children, at home. So we'll go to next slide. Is it boring?
No, ma'am.
No,
No, ma'am.
I'm mixing some activities. Okay. Now we will see some reactions of metals with acids. What is common in acid? Can you think of the acids? Examples of acids. Acids you see, you tell the examples.
Lemon.
Lemon, okay, that is all at household. In the laboratory, HCl, HNO3, isn't it? Can you see?
Yes,
Hey,
ma'am.
children, can you see?
Yes,
I will
ma'am.
change the color of my pen. Then it will be more interesting. Okay, HCl, HNO3, H2SO4. Okay? Any other acid? Hey, you must tell. You must tell. Hey, are you all sleeping? Huh?
Amino acid.
Amino acid. Amino acid is present in both protein. Actually, it contains amine group and acid group. Okay, both basic and acidic group are there. It is not a pakka acid. It's very good answer because you thought about it and it is ending in acid. You told amino acid, but remember, my child, it is not acidic only. It shows both properties because one side is amine group, another side is acid group. So it is not a pakka acid. All right. acetic acid. You know the chemical formula of acetic acid? I have written there. You see that?
Yes, ma'am.
CH3,
Yes, ma'am.
CO.
CO, CH3COH. Okay, so HCl, HNO3, H2SO4, CH3COH. In all these, what is the common factor? What is the common factor? H. Very good, very good. These all contain H plus. Okay, these all can donate H plus. That is the common factor in all protic acid. We cannot call all, we cannot tell all. Exceptions are there. Some other substances are also there which are acidic but does not contain H plus. But commonly we can say acids contain hey, acids contain H plus. Okay. Now we will see one reaction of an acid with metal. That also you might have seen in the laboratory, isn't it? I'm taking zinc pieces. Okay. Zinc pieces are taken. More zinc pieces are taken because I want to get a more reaction from it. So HCl, dilute hydrochloric acid. Dilute hydrochloric acid is added to zinc. Can you see? And then closed with the delivery tube, you see. Then that is dipped in water, you see bubbles. I have done it for some 10 minutes and then showing this to you. Okay. Can you see that tube inside the water?
Yes, ma'am.
Okay. Observe thoroughly. Observe thoroughly. Some bubbles are coming.
Yes.
Yes, ma'am.
What is that bubble?
Yes.
What is that bubble?
Yes.
Hydrogen.
Very good. It is hydrogen gas. Zinc is reacting with the dilute HCl and forms what? Hydrogen gas. We are confirming that it is hydrogen gas by one experiment. Slightly this video is slow, but you please cooperate with me. You just see it, what is happening. Have you seen it in the laboratory? Have you seen it in the laboratory in your lab?
No, ma'am.
Just to see that. Just to see. So zinc is mixed with the what? HCl. Now only I was remembering, if I kept some color paper on the back side, that bubble formation would have been more impressive, isn't it? Next day I will try that. See that bubbles getting accumulated on the surface. Now you must observe. I am doing another thing. You must keenly observe what is going to happen next. See, now bubble formation is more, isn't it?
Yes, ma'am.
Can you say how we test hydrogen gas? How we test hydrogen gas? You don't know. How we test
By
hydrogen
burn, it form a pop-up sound.
Yes, we will see whether we hear a pop sound. You will carefully listen. You are sitting in faraway place. I am sitting in Chikmagalur. Are you able to hear that pop sound? You must tell me. Okay.
It is not reaching
It is chemistry lab of Chikmagalur. Okay. JNV Chikmagalur. Now you see getting accumulated. I was waiting for getting this gas accumulated. Then only that pop sound will be have some sound.
This is a common name.
See. Now I have lighted a matchstick. Just to see. No, not matchstick. Candle. Oh, sound may not be there. Anyway, you have seen it has extinguished. Isn't it?
Yes, ma'am.
What happened there? You tell me. Tell me what happened there. Zinc reacted with the HCl to produce. Zinc reacted with HCl to produce.
Zinc chloride plus hydrogen.
Yes, zinc chloride plus hydrogen. And this hydrogen, in presence of, when it is coming up, in presence of that light, reacts with the oxygen and forms hydrogen reacts with oxygen to form
Water.
Water. It is an exothermic reaction. Okay, I'm writing here that.
Should I remove him?
So zinc reacts with
But he's responding. What?
this is another reaction. Zinc. You are cooperating with me. Thank you so much.
No worries.
Actually, other working area and effective area. ഇതില്ലല്ലോ.
How did you know? So, okay.
See, zinc reacts with
HCl.
HCl produce
Hydrogen
zinc
gas.
chloride and hydrogen gas. Can you balance this equation? You tell me where I have to put some number. Oh, fast.
2HCl.
Yes, very good. 2HCl. This hydrogen gas we saw as bubble. This hydrogen gas is reacting with atmospheric oxygen in the presence of that light, heat of the candle and forms water. When water is formed, it extinguishes that candle. Okay. Light
I used to like
goes.
chemistry.
All right.
Yes, sir.
Okay. Okay, children. So next, not only zinc, many metals are there reacting like this. We'll see. I think this is another experiment. Yes. Iron nail. I have taken iron nail and added hydrogen gas. Can you see the video?
Yes, ma'am.
Iron
Yes.
nail. If you keenly observe, you can see the bubble. Again, it is getting stuck, children, in this video. Lighted matchstick when shone, when taken out again, it is burning. You see, it extinguished. Okay. There also what is happening? There also what is happening? Iron reacts with the HCl to produce. You tell. Hey, children, think. Hey, all of you went for tea, I think.
Hydrogen.
Iron chloride and hydrogen. Okay, balance it. Balance it. Oi,
2HCl.
there also hydrogen gas is produced. This hydrogen gas combines with atmospheric oxygen in presence of that and the extinguishes, forms water there. So the fire extinguishes. Okay, understood?
Yes, sir.
Understood?
Yes, sir.
Okay,
Yes.
all right. Next we will see another activity. See, here I have taken as sodium hydroxide in the bottle, and in the test tube,
How she is
you can see an orange color.
in PPT video.
Okay,
She put the video in PPT.
that orange color reduces and becomes colorless. What I did is, first I took acid and mixed it with the methyl orange. What is done?
Acid is mixed with orange.
Mixed with
Acid
the
is mixed with middle of.
one minute. I will just pause it. Acid is mixed with the methyl orange.
Methyl orange.
What is the color of with methyl orange?
Red.
No, almost orange red, no. So if it is acidic, then it becomes orange red. That is what you have seen first. To that solution, I added sodium hydroxide. So what is happening there? Color reduces. Why the color reduces?
Neutralization.
Yes, very good. The reaction taking place there is neutralization. You see, I will show that once again. See, first that acid with methyl orange, sodium hydroxide is in my hand bottle, and slowly the color is reducing. I have poured also some solution, and finally it took more sodium hydroxide to neutralize it. Now the solution is colorless. Means now neutralization has taken place. Acid has neutralized the base. And when an acid, again next I have taken a base. You see, in that color you see, litmus, with the litmus, slowly it is neutralizing and the color reduces and it becomes colorless. So this is, in this way we can show the neutralization reaction. You see, you will see that reaction taking place. Sodium hydroxide. See, sodium hydroxide is base. It reacts with the HCl to produce, what is produced?
Salt.
What salt?
NaCl.
NaCl and
Water.
water. Very good. Base reacts with the acid to produce salt and SaL2, salt and water. So it is called, what is it known as?
Neutralization reaction.
Neutralization reaction. So remember, what is neutralization reaction? What is neutralization reaction? It is reaction of an acid with a base to produce salt and
Water.
water.
What?
Okay. Now, tell me, anything to ask? So the common ions present in acids, remember it is hydrogen ion. Now we see what all precautions we have to take while handling acids and bases. You tell me what all precautions we have to take.
Is the participation
When
better?
handling?
Wear gloves.
Yes.
It's the same. Only the students
We
We have
willing
to
join
ensure eye
and
protection.
and they only
Yes.
participate.
We must use the good type of test tubes made of glass.
It's
We
like
must
Yeah,
10
borosil glasses. Borosil. We call it borosil. Okay. You see, the exact short form of borosilicate. Actually, that glass is made up of the material called borosilicate. Okay. So borosilicate glasses are to be used. Then
We must take care that it does not
see.
ingest in your body.
Okay, we should not touch this acid or base. No, we should take it in a dropper or pour it to the test tube carefully. All these things we must be careful. So it is
Said mandatory
just
that you
wanted
have to
to
sit
show
inside. Like you have to sit.
borosilicate
Why?
glass. It is made up of borosilicate glass, and we call it borosil glass. The material, the glasses, test tubes in the laboratory, beakers in the laboratory are made up of borosil glass. BOROSIL. And one more thing, important thing is when we dilute an acid, always pour acid to water, not water to acid. That is a very important thing that we must remember, children, because this acid will explode. You see in the second diagram, acid will explode if we add water to acid. Why it is exploding? See, that beaker full contains, that beaker is full, what is present in the beaker? Full acid. So when we add water to it, drop by drop, all these acid molecules will attack water. Okay, the acid needs water. Acid always is loving water. So all the acid molecule will attack water. It causes explosion. And if face is there nearby, face will get burnt or hand will get burnt. So always while dilution, acid must be added to water.
Water.
Water to acid. Okay. You have textbook with you?
No, ma'am.
Yes, ma'am.
Yes, ma'am.
You have?
Yes,
Yes,
ma'am.
ma'am.
Book is there. See question number 2. Question number 2. Take your textbook. See the question number 2. Shall I read the question?
Yes, ma'am.
A solution reacts with the crushed eggshells. Okay. A solution reacts with the crushed eggshells. Solution plus eggshells. What is present in eggshell?
Calcium.
Yes. Calcium carbonate. Calcium carbonate. Calcium carbonate is present in eggshell. No? A solution. Oh, I have not shown you that activity. 1 minute. I missed one activity, children. One activity. After that, we'll answer to this question. You see, can you see this activity?
Yes, ma'am.
Okay. See, I have taken sodium, that is solid is sodium carbonate. Okay. Sodium carbonate. What is the formula of sodium carbonate?
CaCO3.
No. Sodium carbonate. Where is Ca in sodium carbonate?
NaCO3.
Yes. NaCO3 alla. NaCO3 alla.
Na2CO3.
Yes, very good. Na2CO3 is taken. Okay. Now we will see what is done next. Oh, again. Okay. Na2CO3 is taken. And to that, see, I am fixing that cork with the thistle funnel. Have you seen thistle funnel? Thistle funnel. The top like a funnel it is. Hey, children, are you seeing it?
Yes, ma'am.
Into the, I have kept one in the test tube. Lime water is there.
Yes, ma'am.
Lime water. Okay, now I added acid. HCl. Sodium carbonate is there. Acid is added. You see, in the delivery tube, one gas is produced and it is coming and getting dissolved in that solution. Once again, you see, in the first conical flask, what is taken? No, I will show it once again. See, in the conical flask, what is taken?
Sodium carbonate.
Sodium carbonate. Okay. Now, I will close it with that one. In that cork, one thistle funnel is there. One side, one delivery tube is there. Okay. Now that delivery tube is, I thought of adding acid, then I kept it again back. See, kept that lime water below that delivery tube. Lime water. What is the lime water? Hey, you tell me, what is lime water?
Acid.
Lime water is dilute solution of calcium hydroxide. Okay, I'll show that reaction. So it is calcium hydroxide. This one is അതിൻ്റെ സ്പീഡിൽ പോകത്തില്ല. Okay. Thistle funnel connected and the delivery tube is that delivery tube is connected to the test tube containing what?
Lime water.
Lime water is dilute solution of
Calcium hydroxide.
calcium hydroxide. Okay. Yeah, See, lime water is calcium hydroxide. Remember. So, sodium carbonate is treated with the HCl. Okay. Sodium carbonate when reacts with HCl, what is happening? Just I will show. Then I will go back. Na2, CO3. Can you see?
Yes, ma'am.
It's HCl. You tell. You just guess. Whenever we write an equation, we can guess what will be the product. You guess. Just guess. NaCl. Nothing is going to happen if you guess, isn't it? You have all the freedom to guess. Next. NaCl. Any carbonate if added to acid, what may be produced? Some gas is produced. What must be that gas? Yes, correct. Carbon dioxide plus. I'll write here too. Now we see what is left. NaCl, 2 NaCl. We can write 2 NaCl. Then CO2. CO2 is here. What is left?
Hydrogen.
Hydrogen only. CO2 only present here.
H2O.
Yes, H2O. Actually, this is the reaction taking place there. You have seen some bubbles coming, no? That is carbon dioxide gas. That gas, carbon dioxide gas, we are passing through lime water, calcium hydroxide. So, it becomes somewhat milky. It takes some time. It took some time, almost 5-10 minutes to become milky. Milky means something, some white solid which is not soluble in water is produced. Can you guess what may be that solid?
Calcium carbonate.
Very good. Ca, CO2. What will be the byproduct? Ca, C, O2, one more O, CaCO3. What is left here? Correct. H2O. Isn't it? Children, once again you see what we did. HCl is added to. Tell children. HCl is added to sodium carbonate. Sodium carbonate. Then what is the gas produced?
Carbon dioxide.
This gas is passed through
Lime water.
lime water. Then it turns milky because of the formation of this calcium carbonate. Calcium carbonate is not, it's a white colored substance. It is not soluble in water. So we saw that milkiness. Now we will see this experiment once again. Are you tired?
No.
Okay, good. Okay, now sodium carbonate is taken. Sodium carbonate is taken in the conical flask. Why it is called a conical flask?
Because it is in the shape of cone.
Very good. Because it is in the shape of cone. You have studied the shapes in maths. Now it is fixed with a thistle funnel and a delivery tube. And now, first I thought I will add acid, then I kept it back. Before adding acid, I should keep the lime water. No. Lime water is dilute solution of calcium hydroxide. Now added acid. Now if you observe thoroughly, you can see bubble formation inside. And that bubbles are coming and collecting in lime water. Slowly it will turn milky. I kept one paper back of it to make it, because it is white colored and white background. You see, if it was a color, the paper, it would have been better, more better. Now we see that line. Now we see, we can see the whiteness.
Yes, ma'am.
Yes. What is that solid formed in that?
Calcium carbonate.
So remember, this is another experiment. Okay. So in this chapter, you can see so many experiments. And now you can answer to my question. I told you, a solution reacts with the, see, we'll see that. A solution reacts with a solution. What is the solution? We don't know. That is a question. What is the solution? reacts with eggshells. And they are telling, and a gas is produced, okay? A gas is produced that turns lime water milky. Okay, a solution treated with eggshells. What is eggshell?
CaCO.
That calcium carbonate is present. We learned about sodium carbonate with HCl, isn't it? Oh, sorry. Now you see, a solution reacts with calcium carbonate and produces a gas. Now we have to see what must be this gas to turn lime water milky. What must be this gas? If carbon dioxide is to be produced, then calcium carbonate is to be treated with the HCl, an acid, isn't it? It can be HCl or H2SO4 also. HCl is used. HCl is best because byproduct formation and all would be difficult if it is other acids. So question is, if they have given the choices, one is NaCl, okay, next one is HCl, next one LiCl, next one KCl. You have to select the answer. What is the answer?
HCl.
HCl. Very good. You are listening. So we will go back. What all things we learned. Okay, children?
Okay, ma'am.
Okay.
Okay, ma'am.
We will see what all. So what is the common ion present in acids?
Hydrogen ion.
Okay. And what is the reaction of sodium carbonate with HCl? Remember, you remember carbon dioxide gas is produced. Okay. When one thing, children, always when you write an equation, don't by heart it. Okay, you know that this contains. You see, you want to write a reaction between sodium carbonate and HCl. Just write sodium carbonate plus HCl. Then guess the products. You can guess. Sometimes it will be correct, sometimes it will be wrong. All right, and but some products will be correct also. So that will, in that way, you can get interest in writing the equations. Otherwise, you simply write H2 plus Cl2 plus 2 HCl. Like that, if you by heart the equations, you will not get interest at all. So always what you have to do, you want to know the reaction between sodium carbonate and HCl. Write it, guess the products, and then correct it. Always that must be the way of study. Okay?
Yes,
Okay,
ma'am.
children? Next is the neutralization reaction. What is neutralization? Reaction of an acid with a
Base.
base to produce
Salt and water.
Salt and water.
water. Reaction of an acid is sodium hydroxide is acid, HCl is base, salt and water. And through experiment, we have seen how neutralization takes place. Actually, in this class, you have seen some experiments, isn't it? Which help you to understand the concept more. All right? Is it necessary to show the experiment again?
No, ma'am.
Okay. Now we see the reaction of, finally you must remember what happened in each case. You see. So, here, how iron and HCl reacts. Fe plus HCl. You have to write full equation. FeCl2 plus H2. FeCl2, usually children, you make mistake in writing the formulas. For iron chloride, you may write FeCl or something else. The correct one is FeCl2. Another one is also there. FeCl3 is also there and has that property showing multi-valencies. Okay? Variable valencies. Now, what is the reaction of metal with acid? That is what you have studied. Okay? Children?
Yes,
ma'am.
You write in your book this question. Dilute sulfuric acid with zinc. Dilute sulfuric acid with the zinc. Okay? Written.
Yes, ma'am.
It is a question in your exercise. You have to write it You have to write it in the form of equation. Can anybody write and show me that your video? Dilute sulfuric acid and zinc. You can write zinc and dilute sulfuric acid. What is the formula of sulfuric acid?
H2SO4.
H2SO4. Okay, zinc plus Zn plus
H2SO4.
H2SO4 gives ZnSO4 plus. Anybody show me that video? Anybody who has written it, please show me that video. I want to know what you are doing also. Are you having book with you? Oh, I do not summon you.
Yes, ma'am.
Are you having book with you?
Yes, ma'am.
Show that video. I want to see. Switch on the video. Who is showing? Yes, very good. Very good. Give a clap, all others. Give a clap. Very good, very good. Very good, children. Another question. Dilute hydrochloric acid and the magnesium. Very good. Okay, next. Dilute HCl and magnesium. What is the symbol of magnesium?
Mg.
Okay, write the equation. Mg plus
HCl.
HCl gives Mg plus HCl gives. You guess the product.
MgCl2 plus H2.
Very good. MgCl2 plus H2. Balance it. Mg plus.
Mg plus 2HCl.
Yes. Mg plus 2HCl gives MgCl2 plus H2. Okay. Next. Sulfuric acid with the aluminium powder. Sulfuric acid with aluminium powder. I want to know how many of you write it correctly. How many of you will write it correctly? Dilute sulfuric acid with the aluminium powder. Have you written?
Yes, sir.
Read it.
Yes, ma'am.
Read it.
Al2SO4 thrice.
Very good. Al2SO4 thrice. Aluminium plus H2SO4 gives aluminium sulfate. Al2SO4 thrice. There we must be careful. Plus H2. So how to balance it? Al2. So 2 Al. SO4 thrice. So 3H2SO4. 3H2. So that is the equation. Okay? Okay? All these questions you must answer. Okay? Exercise questions you must work out. Another question you must answer to me. Which one of the medicines is used for treating indigestion? Antacid. They have given the options. Antibiotic. Is it antibiotic?
No.
Then they have given the option analgesic.
No, ma'am.
What is analgesic? What is meant by analgesic? Which is used as painkillers. Okay. Analgesic is painkiller. Antacid, that is the correct answer. No. Antiseptic. 4 options are there. What is antiseptic? What is antiseptic? You tell me what is antiseptic. Septic means we tell no, this wound became septic. So to prevent the microbial growth on the wounds, the medicine used is called antiseptic. Antacid is used to reduce acidity of stomach. Analgesic is painkiller. Antibiotic, you know. Antibiotic is used for killing microorganisms and made from microorganisms. Okay. What is the first antibiotic made? Penicillin. Penicillin, isn't it? So, These are the options: antibiotic, analgesic, antacid, antiseptic. Okay, children? Okay? We
Yes,
will
ma'am.
go back.
Okay, ma'am. Can you see
Go
me?
back.
Yes, ma'am, I can see you.
Great. And my slides?
So, you
ma'am.
tell
They are
me
visible.
that color changes of indicators. Red litmus. Red litmus solution changes. Which substance changes the color of red litmus?
Basic
Base.
solution.
Which substance
Base.
changes the color of blue litmus?
Acid.
Acid. Same is the
Acid
condition
of-
with the solutions also, no? Litmus solutions also. Methyl orange with acid,
Orange or
orange or red,
Red.
red only, and with base it is
yellow.
Yellow.
the phenolphthalein.
Yellow.
Colorless
Phenolphthalein.
acid. With
Phenolphthalein
acid,
and
no
acid it
color.
is colorless. Base, actually this is wrong. It is not
Pink,
red.
pink.
It is
Red.
It is not red. Actually, it is violet.
Pink.
Yes, pink. We have seen it. It is pink only. Okay. And the pH ranges, remember, with the universal, what is the color of universal indicator?
Green.
Green color. Green
It
color.
changes base to
Violet.
base.
Violet or blue?
Violet. Yeah,
Violet.
or
Blue.
And acid,
Blue.
Red.
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 Okay. Then with the phenolphthalein, everything over. Okay, children. Thank you so much. Thank you so much.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you.
Thank you, ma'am.
Madam, Samia madam.
Thank you, ma'am.
Yes, ma'am.
Madam, class is over.
Thank you, ma'am. I have recorded the session. For the students who
Okay.
have not attended, I will forward the recording to them.
Is it okay? Okay then. If some more portions are there, whether to be continued, what to do?
Ma'am, as per your convenience, we can accommodate you another class.
Another class. Today's session over now because I have seen 11 o'clock another session is there.
Yes, ma'am. Class 10
Okay,
has
madam.
another.
Then thank you so much for giving me this opportunity. And thanks to all my dear children also who has patiently attended my classes. Thank you. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Ma'am.
Thank you.
സക്സസ്ഫുള്ളി തന്നിട്ടില്ല
എഴുതാൻ
പറ്റില്ല ഇവിടെ ഞാൻ എഴുതി വെച്ചില്ല വേണതാ